The last section in financial math that we are going to cover is section 3.4 out of the textbook. And there are actually two different concepts in this section. The first one is the present value of an annuity, and the other idea is something called amortization. So if we look at our formula sheet for chapter 3, it is going to be, these two formulas are going to be the last two formulas on the formula sheet. So let's scroll down, okay? So in section 3.4, we're going to be covering the present value of an annuity formula and the amortization formula, okay? I am going to cover these concepts not together, separately. I'm going to cover them separately. So if you go into D2L, you're going to see a separate packet of notes for each concept, okay? We're going to start with present value of an annuity, and we're going to learn how to work with that formula when you use it. And then once we've kind of covered that, we will go into a separate note packet and we will work on amortization. Okay, so I just wanted to give you a heads up that there's two different concepts coming out of this section and we will cover them separately. Okay, so we are going to start with the present value of an annuity formula. Okay, so first of all, we have seen an annuity before. Okay, so if you remember earlier in this chapter, we encountered the future value of an annuity formula. Okay, so if you scroll back up on your formula sheet, that was this formula right here. Okay, and we said that you use the future value of an annuity formula when you're saving money, okay, in a savings account, and you're doing so by making regular deposits into your savings account. So you might be putting in money every month or every week, for example, and then you just let that money grow through the regular deposits and through the interest that accumulates, and there are no withdrawals, okay? So future value of an annuity, okay, is a whole different ball game here, okay? It's still going to involve an annuity. Remember, an annuity means just a sequence of regular payments, okay? But like I said, it's a whole different ball game here, okay? So let's talk about when you would actually use this present value of an annuity formula, okay? So if you go to your separate packet of notes for the present value of an annuity, okay? This is the first page, this is what it looks like. So make sure you have this note packet handy, okay? All right, let's read the first bullet point because it's gonna explain to you when you're gonna use this particular formula, okay? The present value of an annuity is the amount of dollars today that a stream of equal future payments is worth. In other words, it is the amount of money you would need to invest today in order to equate to the total of the annuity payments in the future. Okay? If you read through that, okay, you may be totally confused. Okay? That is a very confusing statement. Okay? So I am going to try to translate this for you. Okay? I want to make this clear. The present value of an annuity formula, it is very powerful. It is used in a lot of situations. Unfortunately, it's probably one of the most tricky ones to identify when to use, okay? It involves an annuity, which is a regular sequence of payments, but it also involves a one lump sum, okay? So it's almost like a combination of compound interest where you use that one lump sum and an annuity, okay? So it's a little bit tricky, okay? So let me go back to the formula sheet. I'm going to jot down some notes, and then we're going to do an example, and hopefully that will clarify this whole concept of present value of an annuity, okay? All right, so here's the formula. The big thing with this formula, okay, or how to identify when to use it, okay? Basically, an annuity is being paid out. Okay, so like I said, we're about to do an example that shows you how an annuity is being paid out. Okay, you're not it's not a savings account. Okay, where you're putting money in on a regular basis and then you're trying to figure out how much money is accumulated after a certain amount of time. That's future value of an annuity. Okay, the whole idea here is that your annuity is being paid out, okay? You might be receiving the payments. So the best example of present value of an annuity is retirement, okay? So you might set up a savings account, okay, during your working years where you're saving for retirement. And then once you retire, the money starts coming out of that account, that retirement account. You start being paid, you are being paid money in your retirement years out of that account. Okay, so whatever nest egg has accumulated, okay, you might be receiving a paycheck maybe every month out of that retirement account for you to live on during your retirement years. Okay, the kicker is, okay, yes, you're receiving these regular paychecks. Okay, the annuity is being paid out. So you've got to remember, not only are you receiving these paychecks, but whatever money is still in the account, it's still earning interest. Okay, so that's kind of the whole idea there. Okay, all right. So here's what I need you to know. Okay, PV stands for present value. Okay, so PV is the, whoops, let me erase that. PV is the one lump sum that needs to be invested in order to pay out the annuity. Okay, so PV is the one lump sum that needs to be invested in order to pay out the annuity. Okay, P is the amount of each regular payment to the recipient. Okay, so just from talking about these two variables, you can see how this formula involves both a one lump sum and a regular sequence of payments. Okay, the best thing we can do is look at an example. Okay, so you see in the real world how this works, and hopefully it will clarify things for you. Okay, but you've got to remember the key here is that an annuity is being paid out. Okay, so let's go to our first page of notes. Okay, we've already read through that first bullet point. Okay, in the box below that statement, I have the formula and what the value of the variables means. Okay, let me just again go through that really quickly. I tried to explain that on the formula sheet for you. Okay, the obvious variables are still going to be the interest rate as a decimal. Elm is going to be the number of compoundings per year, how often the interest is being added to the account, like normal. Okay, T is the time and years over which the annuity is being paid out. Okay, so those things are standard. Okay, so PV and P are the variables you really got to understand. Okay, PV, like I've already told you, is the present value of the annuity. Okay, again, I'll notate it on here. Okay, it is the one lump sum that must be invested in order to pay out the annuity. And then when you're looking at the p-value here, it's the periodic payment to the recipient, okay? Because that recipient will be receiving the regular payments, okay? Because your annuity is being paid out. And again, I'll write that here. So the annuity is being paid out. Okay, so let's look at example one, and hopefully this will clarify, oops, paid out. Hopefully it will clarify the situation for you, okay? This first example is going to involve life insurance. Okay, life insurance and retirement, those are the two biggies for present value of an annuity. Okay, all right, just before his first attempt at bungee jumping, John decides to buy a life insurance policy. His annual income at age 30 is $35,000. So he figures he should get enough insurance to provide his wife and new baby with that amount each year for the next 35 years. If the long-term interest rate is 6.7%, what is the present value of John's future annual earnings? In other words, how big of a life insurance policy does he need? Round up to the next $50,000. Okay? Read through this again and again until it's sort of clear to you what's going on and what's being asked. Okay? And then continue the video after you have a good understanding of what's going on here. All right, so what's going on here? John's going bungee jumping, okay? He's a little worried about how that's going to go, so he decides to get a life insurance policy so that if something happens to him, he will, be able to accommodate his wife and new baby with basically his annual income for the next 35 years, okay? So what's going on? He's 30 years old. His current income is $35,000. Okay. He wants his wife and child to be able to receive that same yearly amount for the next 35 years if something were to happen to him. Okay. So he needs to figure out how big of a life insurance policy he needs. And of course, his insurance agent is going to help him with this. Okay. But let's figure out how this works. Okay. This would be an example of a present value of an annuity formula. Okay. Why? Because you have an annuity being paid out. Okay. There is someone receiving regular payments. Okay. If something were to happen to John while he's bungee jumping, okay, his wife and child would receive $35,000 every year for the next 35 years. Okay, so the key here is that an annuity is being paid out. Okay, so we would use this formula for the present value of an annuity. Okay, so you can look at your formula sheet, okay, and see what this formula is. Okay, definitely, again, as we keep going further and further into this chapter, okay, the formulas get more and more complicated, okay? So it looks similar to the future value of an annuity formula, okay, but definitely a little more complicated. One thing you need to realize is the exponent here is negative, so make sure you pick up on that. So you got to pay attention to that when you're using this formula, okay? But here's your formula, and again, you would use this here to figure out, or you're using this here because the annuity is being paid out, okay? Someone is going to be receiving regular payments, okay? All right, so let's talk about what we're looking for and what we know, and then solve the problem, okay? And then after we solve the problem, we're gonna map out this situation to see how it really would work in real life, okay? Let's go ahead and identify the obvious things, the R and the M and the T, and then we'll go into some detail about the PV and the P, okay? All right, so the interest rate is 6.7%, so we need to go ahead and convert that to a decimal, so that's going to be 0.067, okay? M, let's see if we read through this, you don't actually see the phrase compounded such and such in this problem when you read through it, but you're going to have to go on the payments here, okay? So the wife and child would be receiving payments every year, okay? So that's what you're going to have to go on here. So since it's an annual thing, the M value would be 1, okay? So remember, when this annuity is paid out, they will receive $35,000 every year. Whatever is left in the account is still going to earn interest. So not only are you going to have annual payments to the wife and child, but whatever is still in the account is going to accrue interest annually. Those two things will always coincide. Okay. All right. And then the last obvious thing would be time. Okay. We want the wife and child to receive payments over the next 35 years. So time would be a 35-year period. Okay. So let's go and talk about PV and P, okay, because those are the two variables that are left. So one we know, one we're trying to calculate. So let's think about this. Okay, so let me come up here. Okay, so John would want his wife and child to receive $35,000 every year. Okay, so one time a year for the next 35 years. Okay, I I am just going out to the side. I'm trying to think, realistically about this problem. How much at the end of the day, would the wife and child be paid? Okay, so I'm just doing a little rough estimate here. They would get $35,000 every year for 35 years, and that I'm going to go my calculator and punch that in. So let's do that. I'm gonna pull up my calculator. I'm going to get 35,000. Okay, times 35 years. Okay, and so that's a whole lot of money here. Okay, so that's over $1 million. Okay, so I'm going to jot this down. Okay, so if this were to happen and this life insurance policy paid out, the wife and child would receive $1,225,000 over the course of 35 years. Okay, so you want to kind of think of this life insurance policy as this pool of money. Okay, so you have this account that the wife and child would be paid out of. Okay, so this account, when it starts up, okay, the account is not going to have $1,225,000 in it, okay, to fund them, okay. It's going to have a much lesser amount in there, okay, and that much lesser amount, if it is invested as one lump sum, it will pay out the wife and the child $35,000 over the 35-year period. And so they would be paid out the $1,225,000, okay, but not from an account that starts with $1,225,000. A much lesser amount needs to be invested in order to pay out this amount, okay? So we're going to see how this happens, okay? So if you go back to the formula sheet, what did I tell you, okay? What is present value? Present value is the one lump sum that has to be invested in order to pay out the annuity, okay? That is what we're looking for here, okay? That's how much life insurance that John is going to need, okay? This one lump sum he would have to invest, okay, in order to pay his wife and child the $35,000 every year for 35 years, okay? And then P is going to be the amount of each regular payment to the recipient. So here that would be the wife and the child, okay? So in this question, we are looking for the present value, okay? How much life insurance does he need? Meaning, what is the lump sum that has to be invested into this life insurance account in order to pay out the wife and child accordingly, okay? All right, and then the payment to the wife and child, okay, each payment is $35,000, okay? All right, so maybe it's making a little bit of sense to you. Just hang tight. Let's get through the problem, solve for PV, and then we're going to map it out, and hopefully it will make a lot more sense to you, okay? So let's go ahead and plug everything in, okay? So we're looking for PV, okay? We are going to plug in everything else we know. So we're going to have 35,000, okay, times 1 minus 1 plus the R value divided by M. M is 1 here, okay, raised to the negative M times T, okay, and then everything in the numerator is divided by R over M, okay, so that's how you would plug into this. And now we're going to go to our calculator and plug this in, okay. Again, another complicated formula, okay, and I've told you when you have a complicated formula to plug into the calculator, you're going to start inside the square brackets, okay, out of the numerator and denominator. The numerator is more complicated, okay, so we're going to plug that in first, and then once we have that, then we will divide by the denominator, which is the R over M, okay. That will give us the quantity in brackets, and then once we have that, we can multiply by the 35,000 and we will be done, okay. So let's try it. Okay, so pull up your calculator, okay. I'm going to clear this out, okay. I'm going to start inside the brackets in the numerator. So we're going to have 1 minus, open parentheses, 1 plus 0.067 divided by 1, close parentheses, raise it to a power, okay, I'm going to use parentheses just to be safe, my exponent needs to be -1 times 35, close parentheses, and I'm going to get out of the exponent, okay? This is the numerator, so I'm going to hit enter, okay? You have to carry all these digits, okay? You need to divide by the denominator, so I'm going to hit the division key, okay? R over M needs to be in parentheses, okay? Yes, the M value here is 1, so you could just do it in your head, but in case you had something more complicated, R over M needs to be in parentheses or it won't come out correctly, okay? Hit enter. This is going to give you the quantity in brackets, and now we need to multiply by 35,000. Okay, so let's do that. All right, so here we go. This is the final amount, okay? This is going to be a dollars and cents amount because we're dealing with money here, okay? So we're going to have to go and round this to the nearest cent, okay? So let's write this down, okay? I'm going to write down the full decimal expansion that came out of the calculator, and then we will round accordingly. Oops. All right, so let's see here. We've got 35 cents, and then after comes a 3, so we need to stay the same, okay? So this is the exact amount of life insurance that John is going to need, $468,407.35, okay? So this, you know, I don't know if you've ever had to buy life insurance. We're hopefully all young here. You don't go to State Farm or whoever and say, oh, I need to buy $468,407.35 worth of life insurance, okay? You don't have that kind of money sitting around. I don't have that kind of money sitting around. Basically, you have to buy a policy worth this amount. So you pay a monthly fee so that you have a life insurance worth this much, okay? And they don't sell it for, exactly $468,407.35. You usually have to buy them in increments of, 50,000 or something. So that's why you were asked to round up to the next $50,000, okay? So if you rounded this up, John needs a life insurance policy worth, we rounded this up to the next 50,000, that would be $500,000, okay? So again, State Farm or whoever would hook him up with a $500,000 life insurance policy, and he pays some kind of monthly fee to have a life insurance policy worth that amount, okay? All right, so what we're going to do next, okay, I'm going to go back and concentrate on this number because it's the exact number, the $468,407.35, okay? This amount is, and I'm going to write it here, I'm going to use different colors so I can emphasize this to you, okay? What does this mean? Okay, we're going to map this out, okay? This is the one lump sum that needs to be invested in order to pay John's wife and child $35,000 every year for 35 years. Okay? By that one lump sum being invested, okay, the wife and child will be able to receive $35,000 every year for 35 years, okay? We're going to map it out and see how it works because remember, what did we do before we did this problem? We calculated how much the wife and child would actually be paid over the 35-year period, $1,225,000, okay? That's a whole lot more than this amount, okay? So we're going to see how this works. This is a much lesser amount, but it's going to pay out the annuity, and whatever's still in the account is going to earn interest, okay? And because that interest is still accumulating, okay, this lesser amount will pay out the $1,225,000 over the 35-year period, okay? So in the next video, we're going to map out how this lesser amount pays out that much bigger amount, okay? All right, so let's take a look at it.